Let's take a look at this question. It's an easy one. It's called as maximum count of positive integers and negative integers. We are given an array nums which is sorted and in a non-decreasing order. We have to return maximum between the number of positive integers and number of negative integers. Okay, so if the number of positive integer in nums is positive and the number of negative integers is negative, then return the maximum number of positive and negative. Note that 0 is neither positive or non-negative. Okay, so this is what the question is saying. So constraint is for length of nums is 1 to 2000 and nums of I is between minus 2000 to plus 2000 and nums will be sorted in a non-decreasing order. So here in the example, there are 3 negative integers and 3 positive integers. So we return 3 here because maximum count is 3. So here we have to return maximum number, which is the maximum. So in second example, there are also 3 negative integers and only 2 positive integers, right? So maximum count will be 3 for negative integers. And here all are positive integers, so we'll return 4 here because there are no negative integers. So it's like that. Now firstly we'll take a look at how to approach this with the linear search first. It will give us a bad complexity, but then we'll move to our binary search. Linear search, our example was nums minus 5 minus 2 0 0 2 2 and 6. So firstly we mark the indexes here 0 1 2 3 4 5 6. We pointer here first, then we'll make 3 variables here positive. Okay, so firstly we'll check if this is a negative number. Yes, it is a negative number, so we'll make a count here 1. Then we move to our second index, first index. We check again, yes, it is a negative number. Then we go to our second index. This is a no positive, no negative number. It's a 0. So we'll skip this and move to third index. Again, this is 0. So we'll skip to our fourth index. And now we check if it is a positive number. Yes, it is a positive number. So we make a count here and move to fifth index. Yes, it is a positive number. And 6 also is a positive number. So we got a count of 2 and 3. So 3 is greater than 2, then we'll return 3 here. Right. We can also get a count of negative numbers here by doing like this 2 minus 0, like second index and 0 index will give us 2 numbers. We can also get like this. And for positive numbers, we have 7 numbers here, right? So what we'll do, we'll 7 minus 4th index, right? So we got 3 here. So in our code, we'll get the numbers like this. So this complexity will be in the question we were asked to get a complexity of, to get that we'll use binary search. Now we'll see how to code this with the linear search first. Firstly, we'll define our 2 integers, positive and negative. Now we'll start our for loop. We'll just increment these two. Int I is 0, I less than nums dot length and nums plus plus. Sorry, I plus plus. We'll do if nums of I is less than 0, is greater than 0, we'll increment our positive. plus, and if nums of I is less than 0, then we'll increment are negative, and then we'll return their sum or their larger number, max or max, their maximum was, and let's try to run it. Okay, we can now submit it. Now we take a look at how to approach this with the binary search here. So one nums was -3, -1, 0, 0, 1, 1, and 6. We'll mark our indexes here 0, 1, 2, 3, 4, 5, and 6. Put our pointers start and end here. Find the middle. The middle is start plus end minus start by 2. Start is at index 0 and is at 6 minus 0, 0 2, we get third index here. So we go to middle here. Now we can get more than 1 0 in our array. So what we do, we put our end here to m minus 1. Okay, m minus 1. So 3 minus 1 is 2. So this will we are new end here. Now again we perform the operation by finding the new middle here. We get m equals to 0 plus 2 minus 0 by 2. So we got our first index here. So our middle now is here. Okay. Now we know we got our first negative number. So we know that the next number will be our 0. So what we do? We put our start to m plus 1 here this time. Previously we did m minus 1. Now we will do m plus 1. So m is at 1. 1 plus 1 is 2. So here we are index. Second index we will get our start here. Now we can also find our new middle here. M equals to start is at 2 plus 2 minus 2 by 2. So we get 2 plus 0 is 2. So now our middle is here. Now we take a look at how to find our leading numbers here. So we perform a last operation here. When m is less than 0, we find our start by doing m plus 1. But here our m is at value 0. So there is a second condition for this. When m is greater than or equals to 0, so we find our end by doing m minus 1 here. So m is at second index, 2 minus 1 is 1. So our end now will be here. Now we know that there are no numbers between our end and start. So we'll stop our binary search here because we can't find a middle between these two. So we put these two numbers before our start. There are two numbers, so we'll put negative numbers as 2 here. Now we'll start a second binary search and find our positive numbers. Now we find the positive numbers here. So what we'll do, we start again a new binary search and move our n to here. Now start will remain at 2 second index. Middle will be, again we found, middle will be start plus and minus start by 2. Start is at 2, end is at 6 minus 2 by 2. So we got 4 here. So our new middle will be at index 4. Now we know that our middle is uh, greater than 0. So what we'll do? We'll do again m minus 1. So our end will now be at here. Again we find the middle here. Middle will be start is a second plus 3 minus 2 divided by 2. So we got a 2 here. So our middle will now be here. Now we see that our new start will be m plus 1. So we got our start 2 plus 1, that is 3. That is 3 here. Now we find again our middle here. So middle will be 0 will be 3 plus and is at 3 minus 3 by 2. So it will be 0. So we get next 3. So our start is also here. So we got our middle also here. Okay. So now what we'll do? We'll move to our start to m plus 1 here again. And start are overlapping. So we stop our operation here and count these 3 positive numbers after our start. So we got our positive numbers at 3. As 3 is greater than 2, we'll output 3 in our answer. Let's see how to code the binary search code. Firstly, we'll define the n here. N is nums dot length, then our negative position equal to binary search nums, then 0, then r and minus 1. Then we are positive position binary search, again same, nums are negative position and are 0. Our position count will be n minus positive position. Now we return our maximum dot max negative position and positive position. This I think this will be position count. Sorry. Now we can declare a new method here. Public or binary search. Nums array start and our target, you can say target while start is less than greater to n, will initialize the middle value start plus, but this is the how to find the middle here. Start plus n minus start by 2, no? Start by 2, just to be sure here. Nums of our middle is greater than equal to a target, then we'll our start will be middle plus 1, middle plus 1, and else it will be middle minus 1, else and will be middle minus 1. Then we'll just return our start here. Return start. Let's try to run it. cannot find symbol and and. Okay, I forgot to define and here, and will be our n minus 1. Okay, you can now submit it. 100%.